Hey, so we are Tuesday. Feels great. Your exams are up for you to do. And I'm gonna try to keep these lessons as short as possible. There's not too many independent questions. If you find that you understand and they get repetitive, by all means, you don't need to do them all. Okay. So we are looking at combinations of functions. So the first one that we're going to look at is the sum and difference of functions. So when two functions, f of x and g of x, are combined to form the function f plus g of x, or f minus g of x, the new function is called the sum or difference of f and x, or f and g. So the graph of f and g, or f minus g, can be obtained by adding or subtracting corresponding y coordinates. This is called superposition principle. So you've got the sum of f and g, which you do your whole equation, you'll find your y. You do that number and then plus the other number, or you can subtract them. It's not as complicated as making it out to seem. So I'm going to show you how to do it graphically, as well as a few other ways. So let's see here. We're going to use purple today. Okay, so if our x is -3, I'm not going to sit here and do all the math for you. I'm just gonna write the answers. But if you had -3 squared plus 3, it'll give you -6, -1, 2, 3, 2, -1, and -6. Okay, so we can graph that, and that will be, my goodness, at 0 it's 3, at 2 it's -1 and 1, and -2 is here. Okay, and so that, wow, goes like this. Much nicer. We're going to use a different color for the next one. So G, so when we put -3 into here, we are given 6, 4, 2, 0, -2, -4, and -6. That gives us quite literally a straight line, as it is a linear equation. Okay. And that is our g of x. You can do that on both, so I'm not going to bother. That's why there's two graphs. So you can do them both, but so next what you do is you're going to add these two. So that is the sum of f and g. So you'll do -6 plus 6, which is 0. You'll do -1 plus 4, which is 3. 2 plus 2, and so you keep going on like that. And you will regraph that. It's supposed to be a 12. And so your sum of f and g is going to look like this. Okay. Bam. And then you're going to do the same thing. I'm going to use a green for this guy. You're going to do the difference of f and g. So you'll do -6 minus 6, which is -12. -1 minus 4 is -5, and so on. Okay, and if you plot those points, it will give you quite the mess. And this is why we do it on 2 graphs. Okay. I suggest that when you do draw it, you're drawing it on 2 different graphs, but it gives you an idea of what f of x looks like, g of x, the sum of f and g, and then the difference of f and g. So I'm clearing this, and we're going to take a look at how to do it algebraically. Okay. So we are doing the sum on this side. I need my pencil to draw. So the sum on this side, and we'll do the difference on this side. So the sum is f plus g of x is equal to f of x plus g of x, which is equal to negative x squared plus 3 plus negative 2x, which is this. And you're going to complete the square after that to find the vertex. So complete the square to find the vertex. Hopefully you know how to complete the square. If not, I do suggest that either you contact me or you go to Khan Academy or whatnot. So this is what it would be like if you complete the square. I am going to leave that there for now, and then we'll move towards the table and the graph. Okay, so we're going to do the same thing here. So f minus g of x is equal to f of x minus g of x okay, and you're going to find the vertex form, which is, wow, minus g of x. There we go. Okay, plus 4. So I'm going to clear this. I'm going to rewrite the vertex form of those. So that way we can finish this table. So the vertex form of this guy is negative x plus 1 squared plus 4. And then the vertex form of this plus 4. So the vertex of this one is negative 1, 4. So that means that this point here is our vertex. It is our maximum or minimum. And this will be on this side. So there's our first point. You can set your x's to any numbers. It is always best to keep them to these types of numbers. Okay, no. Okay, so negative 2, negative 1, 0, 1, 2, 3, 4. Throw it into this and you will get negative 5, 0, 3, 4, 3, 0, negative 5. And so that'll give you all of these beautiful points. It goes right here. And then negative 4 is negative 5. And 2 is negative 5. Okay. That. You're going to do the same thing here. So this gives you -5, 0, 3, 4, 3, 0, -5, which is all the same points. So at 3, it is 0. Okay, there we go. There. Okay. And that is it. My goodness. Okay. So I'm clearing this so we can go to part 2. So we've got the product and the quotient of functions. So when two functions, f of x and g of x, are combined to form the functions f of g x or f divided by g x, the new function is called the product or quotient of f and x, or f and g. My goodness. Okay, and it could be multiplied or divided by the coordinating y. So we've got our example here. So let f of x equal x plus 3 and g of x, x squared plus 8x plus 15. Okay, so our product is x plus 3 times okay, which can then be factored this way. And so our x-intercepts at 3 and -5. So this is order 2. And this guy is order 1. And so it extends from quadrant 1 to quadrant 3. Okay, so our intercepts are -5 and -3. So this is downwards, up, and like that. Okay. And we've got our next one, which is the quotient of a function. So I'm clearing this. I'm going to push this down, that way we can all have it there. Okay, so we've got our quotient, which is written like that, and we will have it that should be 5. Okay, those will cancel out. So we are left with 1 over x plus 5, meaning that x cannot equal to -5 or -3. Our vertical asymptote will be x equals -5, and our horizontal asymptote is 0. And we have a hole at -3. Okay, so when your denominator is at a lower degree, it's always going to be y equals 0 for your horizontal asymptote. Okay, so this is our first equation, and then we're going to do 1 over x plus 5. So if x is -7, -6, -5.5, -4, -3, you throw that into here, and you'll have -2, -1, -0.5, 0, 0.5, 1, and 2. And then your points here will be this will be -0.5, -1, -2. This is undefined. 2, 1, and undefined. Okay. So I'm going to graph that. So I'm going to have to clear this. So we've got our asymptote going at -5. And at 0 here, those are dots. We've got a hole that's here. So we draw a hole like that, just an empty plot. So it kind of skips that. It's like the one part of the graph that it won't touch. Okay. I didn't touch a single one of those points. And that is it. Okay. So hopefully that makes sense. Hopefully you're able to do it. If not, give me a shout.